Hello, I am Sisir. Today I am going to perform the experiment of force measurement trainer using load cell. There are many types of load cells using which we can measure the force, but today we are going to use cantilever load cell. So let's jump into it. Before discussing the actual experiment, I would like to give you a brief explanation of the theory behind it. So let us go into this. So, as I have said, this is a columnar beam cell. It can be represented as like this. So, this is a highly elastic material. The force will be applied at this end of the load cell. Then then it will observe some strain in it. The strain will be recorded, or the strain will be noticed by the resistance which are attached on top and below the load cell. The formula or the theory for the force for the certain deflection tau can be represented in this form. As we can see, we can record the observations using this cell, but how can we interpret it using this trainer cell? Okay, for that we will be using a Wheatstone bridge. In this Wheatstone bridge, we can see there are four resistance. These four resistance are the ones which we have attached to the load cell. For a balanced Wheatstone bridge, the condition is as follows. If we can see that if R1 or R3 changes, or at least the ratio changes, then we can notice some observable potential change across these points. Through this potential difference, we can measure the strain in this load cell. As mentioned earlier, there will be four resistors attached to the load cell. Those four resistors are nothing but four strain gauges that will be attached. They will also act as signal conditioning unit in our transducer. Let us perform the experiment now. Before performing the experiment, we should adjust the zero, or we should calibrate the equipment. To ensure this, as we can see, there is no load on this load cell. We should adjust the zero. Initially, it is not zero, so we should adjust it. So it is nearly adjusted. Now, to calibrate further, we should use a 1 kg weight and use this adder to make it 1 kg. So as we can see, this equipment is calibrated. So we can now perform the experiment. To do this experiment, we should apply the force gradually, like from 0 grams to 100 grams, then increasing each weight by 100 more grams until we will reach 1 kg. And then we will note the kg readings, and then we'll unload the cell. We'll note the readings further. We have now recorded the readings for the loading part. We'll record the readings for the unloading part. As we have recorded observation, now we'll plot the readings of load versus millivolts and the kgs which we have obtained in this digital voltmeter. After recording the observations of loading and unloading process, I have plotted the data points using MATLAB. So as we can see, the straight line is for the plot of loading and the dotted line is the plot of unloading. We can see that the loading part is almost linear and the unloading part deviates from the loading part. This is due to the hysteresis of the cantilever load cell. So from this experiment, we could conclude one of the advantage of using the strain gauge based load cell is the linearity, and similarly we can observe the disadvantage is hysteresis occurred in the load cell. So it depends upon us whether we should use this load cell or not. This is the main conclusion of the experiment that I have performed in this laboratory. Thank you.